Let's start by inserting the iconic Sydney Harbour Bridge into a Graphs application. On the software, select Insert, followed by Image. Select the image, and then click Open. Now that I have the image in the background of my Graphs application, I want to use a parabola to model one of the arches on the bridge. To make the result reflect the actual measurements, I need to know some information about the bridge. The two granite face pylons are approximately 500 metres apart. The default Windows settings have the pylons appearing at about -6 and 6 along the x-axis, so I need to zoom out to set the scale. I can use the Scratchpad to calculate the zoom factor. 250 divided by 6, so approximately 42. My x-axis settings will therefore need to be approximately -420 to 420. I'll set the x-axis scale as 50. To keep the window aspect ratio square, I need to zoom out by the same factor in the y direction. This time I'll leave the arithmetic up to the calculator and type multiplied by 42. And again, choose a scale of 50. The x-axis is very close to the road level. However, I want to use the sea level as my frame of reference. So, I need to move the Cartesian plane down. I could just click and hold the navigation button and then drag the axis down towards the sea level. Alternatively, if I translate it down by about 60 metres, I'll be in the right spot. So, I'll go back into the Windows settings and add 60 units to both the Ymax and Ymin. Now the x-axis approximates the sea level. The axis is a little hard to see now it's along the waterline, so I'll change the colour. Move the mouse over one of the axes and press Ctrl and Menu. Select the colour. Now we're ready to start modelling the arch. Assuming the arch to be approximately parabolic, I can use the distance between the pylons to help determine an equation. The lower arch comes down close to the waterline at the base of the granite towers. This makes the x-axis intercepts approximately plus or minus 250. The lower arch appears to cross the y-axis at about 110 metres above sea level. So the dilation factor will be 110 divided by 250 squared. And we'll put a negative sign in to flip the parabola up the right way. Modelling curves with equations is not the only reason why you might want to insert an image into your TI Nspire document. Let's have a look at using shapes in the geometry application. I'll start by inserting the geometry application and insert a map of Tasmania. Again, we need to make the map meaningful by adjusting the scale. I happen to know that the straight line distance between Launceston and Hobart is approximately 160 kilometres. So, I'll use a line segment between these two cities. Now measure the distance. And it's approximately 9.7 centimetres. Once again, I'll use the Scratchpad to do a quick calculation. 160 divided by 9.7. That's 16.5. Press Escape to return to the document. Click on the scale in the top right hand corner and change it so that each centimetre on the screen now reads 16.5 kilometres. Notice that the distance between Launceston and Hobart now displays as 160 kilometres. Now I'll use the polygon tool to draw an outline around Tasmania. Use the menu to measure the area of the polygon. Press Ctrl and menu to change the attributes for this measurement. The estimate for the area of Tasmania is between 60 and 70,000 square kilometres, which is pretty accurate. That's all for this session. Be sure to check out our other lessons.